Hello, today we're going to focus on solving absolute value equations. So first of all, as we think about what absolute value is, remember that absolute value is the distance a number is from zero. So absolute value is dealing with distance. So when you think about on the number line, if you were to look at 0 and I go to the left 2 units, if I was to ask what the absolute value of that 2 is, well, the distance from 0 is 2 units. Then you would look to the left and you would say, what is the distance from home to negative 2? 1, 2. So that would be 2 units. So the distance from 0 here would be either 2 units to the left or 2 units to the right. Okay? So when I'm looking at this question, I'm looking for what number I could take the absolute value of and get 7. So from 0, you could go 7 units to the right, or you could go from 0, 7 units to the left. So your two answers for that would be 7 or negative 7. So when I go to this one, can I go any distance from 0, negative 4 units? No. So remember that distance is positive, so you couldn't go any. So it is negative. You cannot be negative 4 away from 0 on the number line. So this would be none, which means that it would have no solution. You cannot go a negative distance. Okay? Remember, these bars are absolute value. And remember that everything in these bars, when you take it out, it is going to be positive because distance is positive. Okay? Distance is positive. So when you take the absolute value of a number, it would come out to be positive. Okay? When I'm looking at solving these equations, you have 4 steps. You want to isolate. You want to create 2 cases. You want to solve. And you want to check. So the first thing is you isolate the absolute value. So what that means is the only thing I want on the side, one side of the equals, is the absolute value bars. Everything else will be on the opposite side. But the only thing that can be on this side is the bars. When you create 2 cases, you set the inside to the bars equal to the positive and the negative value of the number on the opposite side of the equal mark. You're going to solve both equations. You're going to have 2 equations, and then you have to check for extraneous solutions. Now, when you check, you must check in the original problem. Okay? Extraneous solutions are solutions that do not work in the original equation. So basically, these extraneous solutions that do not work would be false solutions. Okay? So this would be where you would not have an answer, it would not work, and it would be false. For example, if I was to go back to this question above, And you can see that the bars are completely isolated, okay? So with the bars being isolated, let me grab one that's not been written on real quick. Okay, so when the bars are isolated, if I set up two cases, I would do x equals -4 or x equals 4. So you change the sign of this in the second equation, and you keep the sign of that number in the first equation. Now, when you check those, and you say, well, is the absolute value of -4 equal to -4? The absolute value of -4 is positive, so that would not equal -4. So this one would not work. When you try the second one in the check, you would have the absolute value of 4 equal to -4. And again, that is going to be a positive 4. That will not work either. So those would be false solutions, which another word for that is extraneous, that you might get as you're going through the problem. Okay? When you work these equations, you will get possibly 3 types of solutions. Okay? The first type, you might get 2 solutions. Another type, one of those solutions might work and the other one might fail, so you might only get 1 solution. If they both fail, like the one that I just did, then you would get no solution. So these right here would be the 3 possibilities that you might get when you're working out your question. Now I'm going to do the left side of this notes, and what I would like for you to do is make sure you're copying these, and when you get finished, you're going to do the evens. So notice that the bars are completely by themselves. So I'm going to set up 2 questions, x minus 9 equals 5, or x minus 9 equals -5. Notice I changed the sign in the second equation to the opposite. You never change anything inside the bars. You always keep that the same. You change the sign outside, okay? So you're going to do the positive and negative value of the number on the opposite side. Then you're going to solve. So this x would be 14. And the second one would be 4. Now, when you check this, I'm going to show you the check by hand. And then you can check these in your head or the calculator. I'm going to show you both. So when you have this number here, it's going to go in replacing x. So we're going to have 14 minus 9. Okay, I take the 14 minus 9 and I get the 5. The absolute value of 5 is 5. So notice that I get the 5 on the other side. So that one does check. Put a little check mark once you check them to show that you have checked. Okay, the second one, you're going to do 4 minus 9 equals 5. 4 minus 9 is -5. The absolute value of -5 is +5. And both of those work there also. So this one checks. So this problem has 2 solutions. One of those is 14. One of those is 4. Now, if you put your answer down, you can write it like this, or sometimes you will see textbooks or standardized tests use set builder, and it would say x equals 4 or 14. So that's what that means when you see it in that set builder form. So those would be your 2 possible solutions, either or. Okay. For number 5, as you look at that one, you see that the bars are not the only thing there on the left. You have a 17 that you're going to have to bring over to the other side, because the only thing you want on the left side are the bars. So we're going to have to subtract that 17. So then you have the absolute value of y minus 1 equals 6. Once the bars are isolated, we're ready to do the two problems. Y minus 1 equals 6, or y minus 1 equals negative 6. I'm going to add the 1 over. Y equals 7. Add the 1 over. Y equals negative 5. So now I'm going to show you how to check these in the calculator. So when you check these, there is a button on your calculator that you can go to call up the absolute value. It's math, number, and then you pick ABS, and it will call up the absolute value symbols. So I'm going to go to the calculator, and I'm going to hit math, calling up the absolute value bars. I'm going to put in a 7 minus 1. To get out of the bars, you right arrow out, and I'm going to add 17. Remember, you plug it into the original problem, not where you've isolated the bars. So that gives me a 23. So notice that 23 was on that side. So when you get that to check, you can also just maybe highlight or box in that answer to show that that one's working. Then I go to the next case. So I'm going to hit math, scrolling over to number. I'm putting in a negative 5 for y this time, minus 1. I right arrow out, I add 17, and I also get 23. So this question works also for that one. So you have two possible solutions. Okay, for number 7, this is 16 times the absolute value. Do not distribute. To get rid of multiply, you're going to divide. So you're going to divide both sides by 16. Negative 32 divided by 16 is going to be negative 2. Now notice that the bars are by themselves. Notice when you're checking, you would have to put something in here to check it. And everything that comes out of that would have to be a positive number. There is no way you can find an answer that would work for R once you subtracted 5 and took the absolute value of it. It would come out to be a positive. And a positive will never equal a negative. So this one would be no solution. Now you could set up your two cases, then you could check in the original problem, and you would see that both of those would fail, just like we did in that problem a minute ago above. Okay, number 9. Question number 9. Sometimes it looks very confusing when the absolute value is on the right. You can always move that over. So I'm going to do 8 minus p minus 11 equals negative 5. So I'm going to keep everything the same. I'm just flip-flopping the sides. Now I'm going to add the 11 over. And that's going to give me a positive 6. Now the bars are isolated, so I do 8 minus p equals 6, or 8 minus p equals negative 6. Subtract the 8. Negative p equals negative 2, so p would equal positive 2. Subtract the 8. Negative p equals negative 14, so p would equal 14. And again, if it's going too fast, just pause the video and you can work these ahead of me and then kind of check your work, okay? So we're going to go to math, and I'm going to go to number, absolute value. I'm going to do 8 minus, and the first p I think I got was a 2. I'm going to right arrow out and minus an 11, and I get the negative 5. For the second one, math, number, absolute value, that's going to be 8 minus 14, right arrow out, minus 11, and we also get negative 5. So both of these would work. So you would put both of those answers down. Okay, for number 11, I'm going to subtract 9 because I have to isolate the bars. I'm bringing down the negative 4 with the C plus 10. That's going to give me negative 24 on the right. I have to get rid of the multiplication, so I'm going to divide. So that's going to be C plus 10 equals 6. Now, some people get really confused on isolating the bars. So what you need to do is look at it like the equations we did. If this problem had said 9 minus 4x equals negative 15, look at the absolute values like it's a big X, okay? If you were isolating this, you would know that's a positive 9. You would know that we would need to subtract 9 to get that to the other side. You would drop the negative 4x, then you would have the negative 24. You would divide by negative 4, and x would come out to be 6. Okay, so notice I did that here. I just have the absolute value equals 6. Now I'm going to set up 2 questions. And this time I'm just going to use dividing lines if you want to do it this way. Some people like to organize that way. Subtracting the 10, we get negative 4. Subtracting the 10, and we get negative 16. So again, don't forget to go back to the original. So I'm going to do 9 minus 4. Going math, absolute value. We're going to put in negative 4 plus 10, and I'm going to right arrow out, and I'm supposed to get negative 15. And I do. So that one works. Then I check the second one, put the minus 4, absolute value bars, and that one is, I think we got negative 16 that time. Negative 16, and then it was plus 10. And that also gives us negative 15. So both of those are working, so that looks good. Okay, the last 2. In question 13, when you have 2 things on the outside of the bars, notice the bars are already isolated and there's 2 parts because a sign, those 2 terms are separated by a plus sign. So you're going to change the sign of both of those. So the first one is x plus 1. The second one, you set that equal to the negative of that, which is going to change both of those signs. Okay, then you're going to bring the variables over here. I'm going to bring it to the left. I'm going to add the 9 to the right. So x would be 5. And then I'm going to add my x here. That's 4x. Add 9. Divide by 4, so x would be 2. Okay, so now we're ready to check that. So we're going to have to put a number in for x on both sides to make sure they equal. So the first one was 3 times our x minus 9. I right arrow out and hit enter. And then on the right side, I put the 2 for the x and plus 1. So notice you get 3 on both sides of the equal. For the second one, I need to put the absolute value. Then I have 3 times 2 minus 9, right arrow out. And then I have 2 plus 1 on the right. And that gives me a 3 also. Okay, maybe I might have checked that one twice. Let me go back and see if I've checked this one. So 3 times 5 minus 9, right arrow out. Yeah, I thought I did. And then the other side is 5 plus 1, which is 6. Okay, so both of these are working. So that one has 2 answers. Okay, the last one for today's lecture. When you look at this one, you're going to need to isolate the bars. So we're going to have to bring the 5 in to the other side. So I'm going to have 8 minus 2n. And then when I add 5 in here, and add 5 in there, it's going to go together to give me 6n plus 2. Now I'm ready to go ahead and make my 2 problems. Remember, do not mess inside the bars. Copy down what you see. And then the second one, you're going to change the signs of both of those. Okay, so I'm going to subtract my 6n. Subtract the 8. Divide by -8. A negative over a negative is a positive. Both of those are even. So that's going to be 3/4. 2 goes into both of those. Okay, and then I'm going to add my 6n. Subtract my 8. Divide by 4. 2 goes into both of those, -5/2. Okay, we need to check. So math, absolute value, 8 minus 2 times 3/4 minus 5 times 3/4. Everywhere you see that letter, you have to put in 3/4. Everywhere you see an N in the original. So that gives you 2.75. On the other side, it says N plus 2. So I do 3/4 plus 2, and that gives you 2.75. So this one works. Okay, on the other side, 8 minus 2 times -5/2. Right arrow out, minus 5 times -5/2, and then enter. Then on the other side, -5/2 plus 2. So these two numbers do not equal each other. So therefore, this solution does not work. That is a false solution. And that's what you call extraneous. That's an extraneous solution. So the only answer is 3/4. Now, I want you to try the right side of those questions and bring those answers tomorrow to class. So go ahead and try the evens, and we'll take a look at the evens tomorrow in the questions that you have. Okay? Have a great day.